In this video, we are going to start our journey into solving word problems that involve systems of linear equations. I'm going to start out with one problem type in this video, and we'll do two types of those problems within that problem type. They're called break-even problems. Now, what it means to break even is to figure out when the cost of something, generally cost, is equal to the amount of money that is brought in. So like a business might bring in money, and then they might lose money for expenses, or maybe travel expenses, or maybe it's how much they pay their employees and how much money they're bringing in per job. So it's cost equals the revenue, the amount of money coming in. So we need both of those equations. I like to do it in two ways. I'm going to show you two ways to set up these equations. It says you start a lawn mowing service and spend $315 on equipment and $4 per lawn is spent on gas and oil. So that's the amount of money you're spending, right? So I'm going to let y, and we'll define variables, y equals, let's do total money. And then we also know that the other variable that we have here is the amount of lawns. How do we know that? Let's keep reading. You charge $25 per lawn. How many lawns must you mow to break even? So the other variable will say x is equal to the number of lawns mowed. So I'll just say number of lawns mowed. Okay, so why does that all matter? Well, we have these two variables, and we actually have two equations here that we could come up with. If we're going to spend $315 and $4 per lawn, that means the total money that we spend, so it's kind of like we have a spend equation, right? So this would be like the cost to us. So this is our spending. The total money, y, is equal to, well, $4 per lawn, that's for gas and oil, plus the $315 in equipment. And that's a one-time $315 fee, right? Because we're not going to be charged at every lawn or we're going to be losing some money. The second equation is the amount that we earn. So I'll call that the earned amount. So the total money we earn, y, is equal to $25 per lawn, which would be 25 for each x. So now we have a system of equations. And I'm going to pause here. When you're learning to do word problems of any variety, this is where you should stop after each problem. So you should do 5 to 10 practice problems and get to this point. So you do the first problem, get here, go to the next problem, get here, go to the third problem, get here. You want to practice the translation part because that's the difficult part. If you're having trouble solving the system of equations, you go back and practice system of equations. Very important here. Okay, so now we go through this and we solve it out. So how do we do that? Well, we have y is that, y is this. We have one variable on its own. So I can use substitution. I'm going to actually substitute 25x in for y right there because y is 25x. So I get 25x is equal to 4x plus 315. Sweet. So now from here, it's a regular equation to solve. I subtract 4x from both sides. Not bad. And we get 21x is equal to 315. All I had left to do is divide both sides by 21. And I'm left with x, because 21's divide out, and I believe that's going to be, let's see, 15. 15 what? Lawns mowed. And we're asked how many lawns must we mow to break even. We're not asked how much total money we would spend or how much total money we would earn. To figure that out, we'd plug 15 into each of these. We would expect the same value though, right? Because to break even means that the money we've spent equals the money we earn. So it takes us 15 lawns before we recoup the money that we lost there. Very cool. To look at it differently, if you think about it, if I'm earning 25 bucks a lawn, I'm losing $4 a lawn, that means I'm gaining $21 per lawn, so that's the 21x that we would have to divide into 315 to figure out how many lawns we're going to mow. Isn't that sweet? On the other side of this video, I'm going to show you a second word problem, a break-even problem, and I'm going to show you a slightly different way to set it up. So if you're looking at this saying, you know what, I don't like that way, I'd rather not use a system of equations, I got you covered. See you on the flip side. And here we are on the flip side, where as promised, I'm going to go over a slightly different kind of break-even problem, and I'm going to present to you a solution method, so a way of solving this thing, that will allow you to avoid using a system of equations if you so choose. So let's check it out. It says you make a down payment of $800 and pay $75 a month for a new TV. So without even I don't know, continuing to read, I'm going to just translate that first sentence. A down payment means that you're not going to pay more than once, right? You pay a one-time fee of $800, and in addition to that, you're paying $75 a month. So that's plus $75 per month. So that's what you are paying for this TV. Your friend makes a down payment of $500 and pays $95 a month for the same TV. So I'm going to write that as an expression. So the down payment is $500 a month plus, sorry, not $500 a month, $500 one-time down payment plus $95 per month. There's an expression there. So we've already read two pretty lengthy sentences and now have these two expressions. Now I will define that M, maybe we'll do this right here, M equals number of months. That way we know what M stands for. Always good to define that variable. After how many months, we're solving for M, will you both have paid the same amount? So what we could do here is we could say, well, this is the amount that you pay, this is the amount your friend pays, and we want to know after how many months will they be the same, or will those amounts be equal? So we skip that whole system of equations part where we're substituting in one equation into the other like we did in the earlier part of the video. A neat way of handling a break-even problem. Now just because the problem didn't say how long till we break even doesn't mean it's not a break-even problem, because we're saying how long until they pay the same amount. That's breaking even. So all we have left to do now is solve. I'm going to subtract 500 from both sides, and that's pretty sweet. So that's going to leave me with 300 plus 75m is equal to 95m. And then I'm going to subtract 75m from both sides, doing a little bit of algebra here. And if you're having trouble solving with variables on both sides of an equation, check out chapter 2 in Algebra 1, where we go over all kinds of how to solve equations. Okay, so 300 is equal to, now the 75m's have canceled, 20m. Ooh, all I got to do is divide by 20 and I'll have my answer. Divide both sides by 20. M is equal to, that 20 cancels out, 15. And it would be 15 months. Have those units there, right? It's not 15 llamas, it's not 15 lamps, or 15 windows. It's 15 months. It's important to have those units, know what you're talking about. A constant reminder that I'll keep giving you in a lot of these videos, I think it's very important that you practice the translation step in getting here. Don't solve out the whole equation. Go to the next word problem and translate again. Much like you would if you're practicing basketball shots. You don't play a whole basketball game just to take 3 shots. You practice that one kind of shot that you want to get better at 100 times, and then you go and apply it to the whole game, just like we do with word problems. Oh yeah, peeps, strategies for learning better.